Hello everyone, my name is Mohammad Jassas. In this presentation, I'm going to talk about our research paper, which titled "An Evaluation of Failure Prediction Model for Large-Scale Cloud Application." As you know, the reliability and availability concerns have become one of the most significant challenges facing both the traditional high-performance computing and the cloud environment. So, with increasing the number of cloud services, the cloud architecture becomes more complicated, and this make the cloud applications have a high probability of failure. Most cloud providers have experienced failure in one of their services. For example, Amazon Web Services experienced failure in one of its services, which is elastic block storage. This failure actually brings down thousands of hosted websites and applications for 24 hours. So many organizations are planning to use the public cloud, but they are concerned about the reliability and availability of the current cloud computing environment. As a result, the cloud providers are responsible for maintaining these services in order to provide the cloud consumer with high quality of service. So the problem is for cloud providers it's not easy to offer 24/7 services uptime. So this is the one of the most significant challenges faced the cloud providers. Another thing, the failed job consume a lot, a lot or a large amount of computational resources and memory. So our objective is to design and implement a failure prediction model that can provide high availability and reliability for cloud environment and also minimize the cost and time of using the cloud. Also, this will save the resources by decreasing the number of failed tasks. And finally, this will help to increase the performance of cloud application. Let us discuss some related work. Many research papers have been published in job failure analysis and characterization of cluster and grid computing. The Google cluster trees are widely used in different research studies. Most of these papers are focusing on workload characterization. There are some papers actually applying a statistical method in order to compare the Google data centers to grid computing or high performance system. So in one of our previous paper, we have studied the Google workload attributes such as memory usage, CPU, and disk space. And actually we find there is a clear correlation between the failed jobs and workload attributes. Most studies have focusing on failure analysis and characterization. There is a limited research has been done on failure prediction. One of interesting paper that published in failure prediction that published by As-Saeed, they have designed a job failure prediction model using a machine learning technique based on random forest classifier. So a comparison with the previous study, we have improved the accuracy and performance of the failure prediction model, and we have achieved a high accuracy for predicting failed class using machine learning techniques. Let us talk about the proposed solution. Figure 1 presents the proposed evaluation process. First of all, we have used three different traces, which are Google, Mustang, and Trinity. And the reason for using different traces is to ensure that the proposed model is is generic and it can be applied to any cloud workload traces. Then we apply the data preprocessing and filtration technique. Then after that, in order to increase the accuracy of our prediction model, we apply different feature selection algorithm in order to select the most important feature that can be used as an input for our proposed model. Then we have applied 4 different classification algorithms to the traces. Then we finally evaluated all models and we selected the best prediction model based on the results. It's important to note that the cloud management system will make the appropriate decision. If the job is predicted as a completed job, the job continues to be submitted as normally scheduled to the available nodes. Otherwise, if the incoming job is predicted as a failed job, the failed mitigation technique will be applied. Let's talk about the experiment and evaluation result. As you can see, the table 1 presents the basic description of each trace. Our experiment utilized 3 different available data sets. Were collected from different organizations, which are Google and Los Alamos National Laboratory. For the experimental setup, we used the scikit-learn, which is the machine learning package in Python. Then we use the power of Microsoft Azure in order to analyze and apply some prediction technique on Google Trace. As you can see in figure 5, which present the performance evaluation of different algorithms applied to the Google Trace, we have run the experiment 2 times. First time when we only use 7 days of the trace, then the second time when we use the whole trace for 29 days. As you can see in figure 5, x-axis present the evaluation matrices and the y-axis present the accuracy percentage. It's clear that after we increase the number of traces observation, the accuracy of evaluation matrix is increased compared to when we just only use that 7 days of the traces. For the Mustang and Trinity traces, we actually use the same classifier that apply in the Google Trace. The random forest and decision tree have achieved the best accuracy compared to other classifier. For Mustang traces, we achieve a high accuracy. However, when we apply the machine learning algorithm to Trinity trace, we didn't get the expected result, or we were not satisfied about the result. So we decide to apply the feature selection algorithms in order to increase the accuracy of our model. As you can see in table 2, when we apply the recursive features elimination technique, we have on Google Trace, we have achieved the highest accuracy. For Mustang and Trinity, when we apply the features importance technique, we have achieved the highest accuracy. In conclusion, we have developed a prediction model for field jobs based on machine learning methods. The proposed model can be applied to large datasets and aim to detect failed jobs before the cloud management system schedule them. Moreover, we have applied different classification algorithms to various workload traces in order to come up with a new general model that can provide a high rate of accuracy of predicting failed jobs. In future work, we are interested to or in developing a model using a deep learning approach in order to improve the accuracy. Besides that, we will consider the mitigation policy and technique. Thank you for listening.